Okay, hello everybody, welcome back. Where we were is geometric sequences, or series. And we showed that if, which is in the form of A times R to the K, where K is 1 to infinity. And we showed that if the absolute value of R is less than 1, then the series converges. And I thought we'd just do a couple examples. The series converges, and actually the sum, the partial sums, I forgot about this. S sub n is A over 1 minus R. That's the sum of the series. And that's where we left off in the last video. I just want to do a couple examples. Term of the sum of, say, 4/3 plus 4. Okay. '81 4/3 plus 4/9 plus 4/27 plus 481. The next one would be 243s, of course. And this whole thing we could represent as 4 times 1/3 to the n. And so R is 1/3. And so we want to find the sum of this series. R is 1/3 because we're multiplying each term by 1/3. That's how we're getting the next successive term. That's what makes it a geometric sequence. So R is 1/3. So what the sum of this series is A, first term, over 1 minus R. R being 1/3. 4/3 over 2/3. 2. This series will add to do the limit of the partial sums as the series goes towards infinity is 2. It will add to 2. Another example, you've perhaps seen these in an Algebra 2 class. 0.515151. An infinitesimal, which establishes a pattern. This is a rational number. And so what we want to do is find the sum of this, determine the sum, and then express as a rational number. Oh, come on. Okay, so what we have here is, let's see, 51, that's hundredths. Plus that 50, plus this 51, which is 0.051, which is 51 10,000ths. 10,000ths, right? I'm gonna have written down. Plus 51. In each case, we're multiplying each one by 100th. 100 times 100. 1, 0, 0. Something like that. Plus, the point is, A is 51 hundredths, or decimal if you want. R is 1 100th. So the sum of that series, oh, sorry, my dog's barking. A over 1 minus R, 51 hundredths divided by 1 minus 1 100th. 51 99ths, if you will. Right there's the, we're done with the rational, we're done with the whole thing. Right there's the rational number. We can reduce this. I think 3 goes into each of these, 17 33s. And so this infinite sequence, this infinite series here, is actually the fraction 17 33rds. Okay, one more. Yeah, definitely. I'm going to erase over here. Whoops. Sorry about that, I didn't mean to do that. I'm going to erase over here. And then, just give you a theorem, and there's a simple test for convergence. And it's a theorem. If the sequence A sub n converges, then the limit of A sub n as n goes to infinity is 0. If it's not 0, if this limit is not 0, then it diverges. One thing I want to point out before we go is the converse of this theorem is not true, and that's the very first thing we're going to do in the next part. Is we're going to talk about something called the harmonics series, in which the limit is 0, but it doesn't converge. This theorem says if it converges, then the limit is 0. Again, we're going to have one that the limit's 0, but it does not converge when we come back. Good luck, everybody. See you next time.